Has it ever occurred to you that there are actually more types of AI? We usually talk about AI in general as being one big technology. However, this isn't entirely precise. Hello and welcome to this video, where we explain the main types of AI. Buckle up and prepare to be amazed, especially by the last two types. Experts agree we can divide AI based on two categories, competency and functionality. If we look at competency, we recognize three types: narrow, general, and superintelligence. Let's check each one by one. 1. Artificial Narrow Intelligence, ANI. All currently existing artificial intelligence, even the most sophisticated and powerful AI yet developed, falls under this category. Artificial Narrow Intelligence, ANI, also referred to as narrow AI or weak AI, is the term used to characterize AI technologies created to execute very particular orders or activities. ANI technologies are created to support and excel in a single cognitive function and cannot learn new skills on their own. To finish these specific tasks, they frequently use neural network methods and machine learning. For instance, natural language processing AI is a type of narrow intelligence. It is capable of recognizing and responding to voice commands, but cannot perform other tasks beyond that. 2. Artificial General Intelligence, AGI. Artificial General Intelligence, also known as strong AI, refers to an AI agent's capacity to think, observe, comprehend, and act exactly like a human being. These systems will be able to independently develop numerous abilities, make links between domains, and draw generalizations, drastically reducing the amount of time required for training. Strong AI has not yet been developed by AI researchers. They would have to devise a way to program computers with the complete range of cognitive abilities necessary for consciousness. Some companies are already working on this. Microsoft has invested through OpenAI $1 billion on general AI. Fujitsu created the K computer, one of the world's fastest supercomputers. It is one of the first relevant attempts to develop powerful AI. However, it took almost 40 minutes to recreate a single second of brain activity. 3. Artificial Superintelligence, ASI. As AGI becomes one of the most powerful forms of intelligence on Earth, the development of artificial superintelligence will likely be the apex of AI research. ASI will be incredibly better at whatever they do because of vastly increased memory, quicker data processing and analysis, and decision-making abilities, in addition to reproducing the complex intelligence of humans. The development of AGI and ASI will result in a situation known as the singularity, which is a futuristic scenario. While it may be tempting to have such formidable tools at our disposal, they might also pose a threat to our existence or, at the very least, our way of life. Check our latest video about singularity to find out more. From a functionality point of view, we have 4 other categories. Functionality refers to a machine learning system's ability to analyze data, react to stimuli, and communicate with its surroundings. As a result, AI can be categorized into 4 functional categories. Reactive machines. These are the earliest varieties of AI systems, and they have very little capabilities. They mimic the capacity of the human mind to react to various stimuli. There is, however, no memory-based functionality. These kinds of robots lack the capacity to learn, or to utilize past experiences to guide the way they operate in the present. They cannot be made to rely on memory to enhance some operations. Deep Blue is one of the best examples of reactive machines. In the late 1990s, IBM's Deep Blue defeated Garry Kasparov in chess. Deep Blue was able to recognize its own pieces as well as those of its opponents on the chessboard in order to make predictions, but it lacked the memory necessary to learn from its prior errors. If you want to find out more about this, check our video about the history of AI. Limited memory. In addition to possessing the characteristics of fully reactive machines, limited memory machines also have the ability to learn from past data and to make judgments. We are aware of almost all applications that fall into this area of AI. All of today's AI systems, including those that employ deep learning, are trained using massive amounts of training data, which they then store in memory to create a reference model for future problem solving. For instance, self-driving cars use AI to monitor the speed, direction, and proximity of other vehicles on the road. This knowledge, which includes knowledge of traffic lights, signs, curves, and bumps in the road, is programmed into the car as its representation of the outside world. The information aids the vehicle in determining when to change lanes in order to avoid colliding with or passing another vehicle. Theory of mind. Theory of mind AI represents an advanced class of technology and exists only as a concept. A theory of mind AI will be able to better understand the entities it is interacting with by discerning their needs, emotions, beliefs, and thought processes. Leading AI researchers are already interested in artificial emotional intelligence, which is currently a growing sector, but progress in other areas of AI will be necessary to reach theory of mind levels of AI. This is due to the fact that AI computers will need to recognize people as unique beings whose minds can be changed by a variety of conditions in order to genuinely grasp human needs. This is equivalent to their understanding of people. Kismet is one application of the theory of mind. A researcher at the Massachusetts Institute of Technology created Kismet, a robot head, in the late 1990s. Kismet is able to simulate and identify human emotions. Both abilities are key advancements in AI, however Kismet can't follow gazes or convey attention to humans. Self-aware. This is the last phase of AI development, which is simply a concept at this point. These systems can detect human emotions and comprehend their internal characteristics, circumstances, and moods. These devices will be more intelligent than the human brain. In addition to being able to recognize and elicit emotions, this kind of AI will also possess emotions, needs, and beliefs of its own. In short, it will be self-aware. It has always been and will always be the ultimate goal of all AI research to develop this kind of AI, which is decades, if not centuries, away from becoming a reality. And this is the kind of AI that the technology's gloomy forecasters are scared of. Thank you for watching. If you enjoyed our video, like and subscribe.